All right, today's notes are on solving systems of equations by graphing. So a little bit of review. Writing equations in slope-intercept form allows us to quickly determine the slope and the y-intercept of a line to graph. So here's some examples. I want to determine the slope and the y-intercept of the equations below. So right away, this is already in slope-intercept form because it looks like y equals mx plus b. So I can jump in and already tell you that the slope in my case is going to be 3 and that my b is going to be -4. Remember, my slope is m. So this is telling me that my rise over run that's not a fraction, right? It's going to be, I need to write it as a fraction, so I just put a 1 under it, which is telling me that this thing is going up 3 units and right 1. So if I were to graph it, I know it'd go up 3, right 1, up 3, right 1, up 3, right 1. In this case, also, that it's telling me that b is equal to -4. This thing is my y-intercept. So this is where I would graph, that would be my first dot, right? On the y-axis, I would graph it at -4. And then from there, I go up 3, right 1. Okay, on this one, I got 2x plus 3y equals 15. This is not in slope-intercept form. Remember, slope-intercept form means y equals mx plus b. And to make it look like this, I need to isolate the y. Right now, that y is not isolated. So before I even try to talk about the slope or the y-intercept, I need to get that y isolated. So right now, that 3y is being added by 2x. I can get rid of that by subtracting 2x on each side. These are going to cancel. I'm left with 3y is equal to, I can't combine these, so I'm going to leave this as -2x plus a positive 15. And then everything's going to get divided by 3, so I can isolate that y. Divide by 3, divide by 3, divide by 3. These are going to cancel, and I'm left with y equals, let's leave this as a fraction, -2 over 3x plus, and then 15 divided by 3 is just 5. Now it looks like slope-intercept form, so now I can start talking about the slope and I can start talking about the y-intercept. I know that in this case, my slope is -2 over 3, which is the same thing as my rise over run, which means this thing is telling me to go down 2 and then right 3. Remember that down 2 because of that negative, right? So I know exactly what to do with my graph once I get the y-intercept. What's my y-intercept? Well, in this case, my y-intercept is 5. Sorry, let me go ahead and do that in blue. My b is equal to 5, which means my y-intercept is equal to 5. So on the y-axis, I would start 5 units up and plot it right on the y-axis. All right, so a little bit of review, just in case you forgot. So today we're going to be working with the system of equations. A system of equations is a set of 2 or more equations that are being solved at the same time. Now, as far as solutions to systems, well, there's two different types of solutions that we really work with in mathematics. The first one is going to be an x and y value that make both equations true when plugged in. So let me go ahead and highlight that. So if I'm just talking about the equations, then I want an x and a y that makes both of them true. And if I'm talking about a graph, then it's the point x comma y where the two lines intersect. Where do they cross each other? On the line. And we'll talk about that as we move along. So on the first example, it says determine whether each point is a solution to the system of equations. Remember, a system means there's two or more equations. And if it's going to be a solution to the system, it's got to work for both equations. It can't just work for one. So we're going to check if the point -3 comma 2 is a solution to the system x plus 5y equals 7 and -2x plus y equals 8. It's got to work for both in order for this to be a solution. So let me go ahead and plug this in. Remember that this is my x and this is my y. So I'm going to go ahead and take that and I'm going to substitute it into my equation. Let me substitute it into this first equation here. When I do that, I get -3 plus 5 times my y. My y is 2, so let me go ahead and put that in parentheses since it's right next to it. Is equal to 7. That's going to be -3 plus 10 is equal to 7. And -3 plus 10, that's 7 equals to 7. It looks like it works so far. It worked for the first equation. That's not enough, right? It's got to work for both. So I'm going to go ahead and now I'm going to substitute the negative 3 comma 2 into the second equation right here. So let's see if it works here. Over here, I got a negative 2 times my x. My x is negative 3. Plus my y, which is just 2, is equal to 8. That's going to be a positive 6 plus 2 equals 8. That means an 8 equals an 8. And guess what? That works as well. Since it worked for both equations, the negative 3 comma 2 worked for both equations, I get to say that yes, it is a solution. It worked for both equations. All right, so that takes care of my first one. Let's take a look and jump into the next one. I want to see if 2 comma 1 is a solution to my system. That means the 2 comma 1 needs to work for both. As soon as it doesn't work for one, it doesn't matter if it works for the other one. It's got to work for both at the same time. So here's my x and here's my y. I'm going to go ahead and substitute it in. I'm going to write 1. I'm going to do this one first. 1 is equal to negative 3 times my x, which is 2, plus 7. That's 1 is equal to negative 6 plus 7. 1 is equal to 1. Oh, it looks like it works. So far, it looks like it might be a solution, but remember, it's got to work for both. So let me go ahead and check the other one. I'm going to go ahead and plug 2 comma 1 into that equation. What I should write is, sorry, I messed up. I should be writing 2 times my x. My x in this case is 2, minus my y, which in this case is 1, is equal to negative 5. That means 4 minus 1 is equal to negative 5. That means 3 equals negative 5, and that did not work. As soon as it doesn't work for one, it's no longer a solution. So if it would have messed up on the first one, I didn't even have to check the second one. But in this case, it worked for the first. It did not work for the second. Therefore, I'm going to write not a solution. It needs to work for both in order for them to be considered a solution. All right, that takes care of the first one. And let's go ahead and scroll down. So if you want to check to see if a point is a solution to the system, you just plug them in. In this case, though, it says solve the systems below by graphing. So again, they're giving me 2 equations. In order for it to be a solution to the system, it's got to work for the first equation. It's got to work for the second equation. That means we're going to try to see what points I'm going to plot. So let's go ahead and plot the first one. The first one is y equals 1/2 x minus 2. So let me go ahead and graph this one. Remember, if it's in y equals mx plus b form, it actually makes it really easy because I know exactly where to start my graph. I'm going to start my graph on the y-axis at negative 2. And then the slope of 1/2, well, that's telling me that this needs to go up 1 and then right 2. So from the dot at negative 2, I'm going to go up 1, right 2, put a dot, up 1, right 2, put a dot, up 1, right 2, put a dot. We're going to go ahead and go all the way. And then we're going to do the exact same thing going in the opposite direction. So instead of up 1, right 2, we're going to go down 1, left 2, down 1, left 2, down 1, left 2, all the way through. Remember, I've been graphing these for a long time, so I'm really fast with these dots. If you need to hit pause on the video and slow down, make sure you get those straight lines, okay? Make sure you press pause if that's something that you need to do. Let's go ahead and do the next line. It's also in slope-intercept form, which is great. And that's telling me I need to start my graph at negative 5. So here's my dot. And the slope is 2. Remember, if we don't have a rise over run, we're going to just make it into a fraction. That 2 means rise 2, and then the 1 means run 1. So I'm going to go up 2, right 1, put a dot, up 2, right 1, put a dot, up 2, right 1, all the way through. And then once I'm done with that one, I'm going to go in the opposite direction. I'm going to go down 2, left 1, down 2, left 1, and that's as far as I can go. We're going to go ahead and get a straight edge. We're going to connect those dots. You get a graph that looks like that. Remember, in order for it to be a solution to the system, it's got to be on both. So this dot right here, it works for the red one, but it doesn't work for the blue one, right? It's on the red line, but it's not on the blue line. And this dot right here, well, that dot works on the blue line, but it doesn't work on the red line. The only spot where it works for both would be the intersection, which is right here. This dot right there, I want you to highlight it. That dot is on the red line and it is on the blue line. So that dot works for both. That is my solution to my system. So I'm going to go ahead and write, this is my solution right here. We're going to write our solution as an ordered pair. I'm going to say 2 comma negative 1 is my solution. That is the only dot that appears on both graphs. So essentially, all you have to do is graph both lines, and once you graph them both, then you should have your answer of where the solution is. All right, let's try the next one. Unfortunately, on the next one, they're making us do a lot of work because I can't graph that since it's not in slope-intercept form. Remember, to get it in slope-intercept form, you want to make it look like y equals mx plus b, which means you need to isolate the y. So let me go ahead and isolate that y. On the first one, let's see, I'm going to write x minus 2y equals negative 4. We're going to try to get the y by itself. Right now, I have that x in the front, so I can get rid of that positive x with a minus x. These are going to cancel. I'm left with negative 2y is equal to negative x minus 4. And then everything's going to get divided by negative 2. Divide by negative 2. Divide by negative 2. These are going to cancel. I'm left with y equals, I have a negative divided by a negative. That's going to be a positive. And because it's just, there's no number in front of that x, I know it's a 1x over 2. I'm put the x on the side. Negative 4 divided by negative 2, that's going to give me a positive 2. And now I can finally start graphing that. That's y equals 1/2 x plus 2, which means start on the y-axis at 2. That 1 is telling me to go up 1. The 2 is telling me to go to right 2. So from here, I'm going to go up 1, right 2, put a dot. Up 1, right 2, put a dot. Up 1, right 2, all the way through. And in the opposite direction, down 1, left 2, put a dot. Down 1, left 2, put a dot. Down 1, left 2, all the way through. That takes care of the first graph. Now I need to do the exact same thing with my second graph. So I'm going to write x plus y is equal to negative 1. It's not in slope-intercept form. We're going to isolate the y. I'm going to subtract x on each side because right now it's being added by x. These are going to cancel, and I'm left with y equals negative x minus 1. So let's go ahead and graph that. It's going to start at negative 1. That slope right here, it's not a fraction, so let's put it over 1. And remember that that actually means negative 1x over 1, right? So we're going to go ahead and change that to y equals negative 1 over 1x minus 1. That's telling me to go down 1 and then right 1. So from here, I'm going to go down 1, right 1, put a dot, down 1, right 1, put a dot, down 1, right 1, put a dot. And I'm just going to go ahead and do this rather quickly. It should go on a perfect diagonal right there. And then in the opposite direction, we're going to go up 1, left 1, put a dot, up 1, left 1, put a dot, and we're going to continue that line all the way through. Okay, now that I have it, I'm just going to go ahead and connect these. Again, if I'm going too fast, press pause on the video and catch up when you are comfortable with your graph, okay? We're going to look and see which point is on both graphs. Well, the only point that's on both graphs would be this point right here. So this must be my solution. And so because of that, I get to write that the coordinates negative 2, comma 1 is my solution. Because that's the only dot that's on both graphs, right? It's the only place that both equations are going to work. All right, so that takes care of the front side. We only got 2 more questions on the back side, and we'll take care of the notes. Let's take a look at the first one. I got y equals x minus 3. That's already in slope-intercept form, so they're going to save me a ton of time on that. I know that the slope in this case, well, that's not a fraction, so let's make that into a fraction. I'm going to put it over 1, and we're going to put a 1 in the front as well. So that's telling me to go up 1, right 1, up 1, right 1, up 1, right 1. So from start at negative 3 on my graph. And I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, and we're just going to put a bunch of dots going across that diagonal, it looks like. And in the opposite direction, you go down 1, left 1, down 1, left 1, down 1, left 1, all the way through. My first graph looks like this. On my second graph, it says x equals 4. Now, I don't know if you guys remember, because it's been a while, that is a special type of looking line, and students will get this confused. Sometimes students will draw it vertically. Sometimes they'll draw it horizontally because they're not really sure. And the easiest way I told you to remember is like, hey, when you graph x equals 4, you're going to draw your x-axis, you're going to draw your y-axis, and you're going to put a dot exactly where they told you. They said x equals 4. So on the x-axis, we're going to put a dot at 4. And since I'm going to put a dot at 4, I'm going to draw a line that goes through that dot. Well, if it's going through the x-axis, then I'm not going to draw it this way. That doesn't make sense. We're going to draw a line that goes through the x-axis. That means you must have a vertical line going through the x-axis like this. Alternatively, you can just memorize like, oh, the x equals line is a vertical line and the y equals line is a horizontal line. All right, let's take a look at where these two intersect. It looks like the intersection point is right here. That means this is going to be my solution right here. And the coordinates for that dot is going to be the coordinates 4, 1. So I'm going to write 4, 1 is my solution. All right, down to the last one. I got y equals 3x plus 2. Okay, that one's easy because it's already in slope-intercept form. So I'm going to put a dot at 2. And the slope of 3x plus 2, remember that we need to change that into a fraction. So that's telling me to go up 3, right 1. So let's see. I'm going to go up 3, right 1, put a dot. Up 3, right 1, put a dot. I can't do it again. I'm going to do the exact same thing in the opposite direction. I'm going to go down 3, left 1, put a dot. Down 3, left 1, put a dot. Down 3, left 1, put a dot. And it looks like I can do it one more time. All right, we're going to go ahead and connect this line right here. It's going to go straight through. Got my first equation down. Let's take a look at the second one. The second one is not in slope-intercept form. So I need to change the way it looks. It's going to be negative 6x plus 2y is equal to 0. I'm going to isolate my y value. So let's get rid of the negative 6x. I'm going to add 6x to both sides. These are going to cancel. I'm left with 2y is equal to 6x. Divide both sides by 2. I get y equals 3x. Now, students sometimes get really apprehensive when they do this because they go, where's my y-intercept? I don't have a b. Where's the b? What do I do? Where do I go? Well, if there is no y-intercept, that means there's nothing there. And we have a number for nothing, right? The number for nothing is 0. So you can think of this as y equals 3x plus 0, which means on the y-axis, you're going to start your graph at 0. And then since your slope is 3, we're going to make that 3 over 1, which is telling you you need to go up 3, right 1, up 3, right 1, put a dot, up 3, right 1, put a dot, up 3, right 1, put a dot. Doing the exact same thing in the opposite direction, we're going to go down 3, left 1, put a dot, down 3, left 1, put a dot, down 3, left 1, put a dot, and we're going to go ahead and connect this line. When you do that, take a look at those two lines. They're not crossing. And it doesn't look like they're going to cross because I don't know if you remember a few weeks ago we went over parallel lines and perpendicular lines. Well, these lines are parallel. I know they're parallel because they have the same slope. That means they're growing at the same rate, but they started at a different spot. So they're never going to cross. And I said the solutions are where they're going to cross, but they're never going to cross. So we're not going to have any solutions. In this case, we can say that we have no solution. All right, those are all the notes for today. As always, if you have any questions, feel free to ask.